Alright, so Coulomb's law, we're going to do this page. We're going to skip around because it's so similar to the stuff we did in the gravity unit, which you did it recently or you've done it a little time ago. Super easy. One thing I want to do real quick is I want to read from your reading material. We're going to read right here, Coulomb's law. I'm going to read that off screen. So two objects attract each other with a force that is proportional to the charge of the objects and inversely proportional to the square of the distance. In other words, if you increase either one of these by like double, you double this. If you double the distance, that means it's going to be 2 squared. You make this 4 times weaker. Likewise, if you reduce the distance by 2 squared, that means this is 4 times stronger. And if you reduce one of these charges in half, that means this is half as strong. Okay, let's do a few of these and it'll make sense. Not very difficult. Number 1. Two charges have a repulsive force of 0.8 newtons. So that's our force, right? 0.8. If the charge, so we're dealing with Q, of one of the objects is doubled, what is the new force? Well, if you remember, this is directly proportional. Directly. This is indirectly. So we doubled the force, which means we doubled the charge, which means that's gonna double the force. Well, 0.08 doubled is 0.16. That's easy, right? Alright, so let's skip to number 3. If two charged objects have a repulsive force of 0.08 newtons again, the distance separating them is doubled. So in other words, it's normally d squared. Now it's 2d squared, which means you can square this too, so it's 4. So the distance is times 4, right? Then what is the new force? So this 4, remember, it's on the bottom, which means the new force is divided by 4. So 0.08 divided by 4 is 0.02. That's easy, right? Okay, so this one deals with only charge, this one deals with only distance, this one deals with both. So remember, you're going to be doing one of a couple things. Sometimes two of a couple things, I guess. Multiplying only, dividing only, or multiplying and dividing. That's it. So I'm going to go number 8. Randomly picking one. Okay, so again, same charge, 0.08 newtons. Newtons, so it means it's force. The charge of both objects is doubled. Both objects, right? So that means times 2 times 2, right? So times 4 essentially, right? The distance separating the objects is doubled. So that means, remember, 2d, it's doubled, which means it's divided by 4, right? So what happens if we do times 2 is 4, times 4 divided by 4? What do you think that's going to do to this? If I multiply it by 4, then I divide it by 4. Think about it. If I'm like, hey, listen, how much money did you make today in your paycheck? Okay, well, I'm going to double it, and then I'm going to cut it in half. Well, guess what? That's going to do nothing. You're going to have the exact same amount you started with, right? You double this. Actually, we already said this, I think. Well, we doubled it once, but more or less, it's going to end up the same, 0.08. So with these, just take them one step at a time. What do you do to the numerator? Or what do you do when they change the charge? And then do what you do when they change the distance. That's it. Piece of cake. So we did one of each. More or less, they're all the same. You're just going to do a different quantity. Should be a piece of cake. You actually don't need to put newtons there. I just did out of habit. That's it. I know this is very brief, but that's the way it is. Bam.